Proton has massive CPU overhead on some systems. Game developers need to be making native Linux builds. Compatibility layers will never be as good as native support and optimization. I was just hoping that Linux would keep gaining support so I could leave Microsoft behind forever. It's clear that there are some people who don't understand Proton, so let's talk about it. So what is Proton? To put it simply, Proton is a compatibility layer for Windows applications on Linux. But you've probably heard that before, compatibility layer. For someone who's not in the know, that's just jargon. So let's actually figure this out together. What is a compatibility layer? Before we answer that question, we need to start with the basics. A computer is a miraculous little machine, generally made up of smaller components that work together to process input and turn it into output. At its most basic level, computers generally include long-term storage, short-term storage, some kind of human interface, visual and audio output, and a central processing unit that orchestrates all of these pieces. In the case of the NES, for example, the cartridge would be the long-term storage, the RAM would be the short-term memory, the controller would be the human interface, the TV would be the audio and video output, and the Zilog Z80 would be the CPU. When a developer is writing a game for the NES, they have to create code that the Z80 understands. These are called instructions, and there's a predefined set of instructions that the Z80 knows how to follow. NES games were written specifically for the NES. If you were to take the instructions from, say, Super Mario Bros. 3, for example, and try to run it on your PC, you wouldn't get very far because your 64-bit x86 CPU doesn't speak the same language as the Z80. That is, at least not without some piece of software that knows how to convert the Z80 instructions into something your CPU understands. We call this conversion process emulation, which you've probably heard before. Emulators have to spend a ton of your computer's resources pretending to be the chips in the NES and converting the game's CPU instructions into something that your PC can understand. But that's not all. It also has to adapt the NES's graphical routines and output that into something that the software can render on screen. It also has to completely synthesize in software the NES's audio chip signals. It has to allot and manage the entirety of the NES's physical RAM in software, and it has to convert modern controller inputs into an NES's controller signals for the game to interpret. So it's no surprise to say that emulation is resource intensive and it's expensive. And now is a good time to mention that Proton is not an emulator in any way. I mean, think about it. What's the difference between your PC's x86 CPU when you're running Windows versus when you're running Linux? That's right, regardless of what operating system is running on your PC, the hardware stays the same. So at a fundamental level, your PC knows how to run PC software. So then why doesn't it work? Let's talk about operating systems for a minute. An operating system is a software layer that lives between the hardware and other software on your computer. The OS manages the hardware. It enables features like multitasking, it provides common services, and it makes software development easier. Operating systems are made up of a few components. First is the kernel, which is responsible for answering system calls from other software and coordinating the user's software with the computer's hardware. Usually, hardware drivers live at the kernel level, and drivers teach the kernel how to talk to the hardware they're written for. Just above the kernel level is a layer of APIs. APIs are specialized libraries that allow for different hardware and software components in your computer to talk to each other in an expedited way. Vulkan and DirectX are two widely known APIs that are used to render hardware-accelerated graphics. Finally, there's user software that sits on top of the API layer. This is often called user space. So now we know the basics of an operating system, and it may come as no surprise that Linux, macOS, Windows, and other operating systems were all designed differently from each other. Well, at least kinda. See, macOS and Linux, they're kinda like cousins. They share a similar design, at least when it comes to the basics. Windows, though, well, it's a hodgepodge of corporate acquisitions and rival internal interests at Microsoft, and let's just say that it's very, very different in terms of its design, especially when compared to Linux or macOS. So now we can finally answer the question. If it's not an emulator, what is a compatibility layer? Well, let's think of an operating system in terms of a town. Most towns have a bank, a post office, a grocery store, as well as various downtown shops and residences. The only thing that's going to be different is where you can find the various services a town has to offer. Compatibility layers, first and foremost, act as a map that can tell visitors, in this case software, where to find the post office or the bank or the grocery store. Maps are simple and straightforward. So when you load up a Windows game through Proton, in the best case scenario, Proton just tells the Windows app how to access something like Vulkan. Seriously, the Vulkan API is the same regardless of operating system. So if a game uses Vulkan or OpenGL, then it just has to talk to the GPU in the language that they're already both speaking. It's not always that simple though. Many Windows games use DirectX instead of standardized APIs like Vulkan. And since Microsoft keeps DirectX closed source and proprietary, Proton needs to convert DirectX API calls into Vulkan. Since Vulkan is usually far more performant than DirectX in like-for-like calls, this can lead to Windows games running at significantly higher frame rates on Linux than on Windows. There are various other things that Proton does too. Sometimes a Windows system call might provide you with, let's say, a 32-bit number with no decimal places, when a comparable Linux system call might provide a 64-bit number with decimal places. If a game is expecting one and receives the other, it's going to crash. So in these cases, Proton actually translates the result of a Linux system call to something that the game would expect. In other words, a translation or a compatibility layer. Now the list goes on, and when you hear someone say something like, well, Proton adds too much overhead, that really isn't true. In many cases, it's just acting like a map. In others, it's simply converting values to different formats. It's a rare occasion that Proton has to do a ton of extra work to provide a Windows-like output, and that's really what it's trying to do. Proton essentially provides a Windows-like software environment for Linux. There's no emulation here, since all PC games are compiled for x86 CPUs, and games under Proton often get better frame rates than they do on Windows, since Vulkan is so much faster than DirectX. So then why are some games incompatible? That's a great question. Before we move on, I gotta ask you a question. You find this video interesting? You enjoying it? You learning something? You can spread the word by sharing this video with your friends or on Reddit or wherever. You can also like that smash button. It's the best way to tell YouTube you want to see more videos just like this. And finally, you can get subscribed if that's more your speed. All right, let's get back to it. Windows is a massive ecosystem with sometimes dozens of APIs that all do the same thing. There have been 12 different versions of DirectX, and most of them are vastly different from each other. I mean, Windows has been around for nearly 40 years, and DOS, the OS that Windows is actually based on, dates back to 1980. Suffice it to say, Windows is old, and the growing pains are there to prove it. So why then are some games incompatible with Proton? Well, Proton has a majority of the Windows APIs covered, right? But it doesn't actually have every single one. That could be because Microsoft has not documented every system call, which is the case. Or it could be that a missing system call is just so seldom used that it just hasn't been worth it to implement in Proton. Sometimes it doesn't perfectly translate the values it gets from the Linux system call to a game and it crashes because of that. Sometimes, and actually in most cases, it's the fault of kernel level anti-cheat. It's the game's fault. This is because there isn't a real Windows kernel available for it to sink its hooks into, and the anti-cheat software detects that something is wrong and prevents the game from working. Often, a game isn't compatible with Proton because a developer goes out of their way to make it incompatible. Bungie, for example, decided that Destiny 2 wasn't compatible with Proton, and they threatened to ban anyone who tried it. Which, hey, I mean, it's their game. Good for them, I guess. However, most developers are cool, and they let Valve provide Proton support for free. So unless you're playing this year's hot new competitive online shooter, you'd be hard-pressed to even notice that a game is running in Proton versus through Windows. Shouldn't we demand native games, though? No, we shouldn't. Here's why. Game development is an extremely cost-sensitive endeavor. Believe me, I know. And despite the fact that we've got some 6 to 7 million monthly active Steam users on Linux, we're still only about, 2% of the total Steam user base? So let's imagine that you're a development studio and you're looking into the idea of publishing a game for Linux. In a lot of cases, that's going to add 6 months of development time at the bare minimum, and a ton more time if your engine doesn't actually support building games for Linux already. This will also mean that you're going to have to hire specialized engineers who have a very unique skill set, including Linux kernel development, expertise in Vulkan, experience with software optimization, and more. And you're going to have to pay them a premium for their skills while you're at it. And after launch, you're going to need to publish your updates for all supported platforms, which includes more time and money spent testing and bug fixing. Finally, in some instances where we can compare head-to-head Windows builds running through Proton versus a native Linux build, we find that the Windows builds tend to just run better than the native Linux clients do. How is that even possible, you might ask? Well, it comes down to familiarity. If you took a carpenter from the 1880s and brought him forward in time to today, gave him modern tools, and had him try to build a house, I suspect you'd end up with less than stellar results. The carpenter in this scenario is a developer who's familiar with using Windows, if that wasn't clear. It's just most game developers are more familiar with the tools that Windows provides, and they're able to optimize more efficiently on Windows. Those optimizations in a Windows build running through Proton carry over to Linux, and they just tend to run better on Linux in many cases. Now, it's not a bad thing to have a Linux build of your game, and many native builds provide superior performance to their Windows counterparts. But demanding a native Linux build for every game is short-sighted at best, and it ignores the wider economic and skill constraints of game dev. And it's just not possible. Like I said, we're only around 6.5 million or so Linux users on Steam, and that's not a big enough market to support AAA releases, or even like many smaller releases. For the most part, Proton provides a simple, easy way for Windows games to just work on Linux. It's not foolproof, it's not perfect, but it's open source. It's constantly improving. In many ways, it's already better than Windows, and I believe that it'll soon be the baseline for PC gaming as a whole. I want to give a special shout out to my patrons, these guys over here. It's because of their continued support that I've been able to make this show into what it is today, so thank you. If you believe in the work that I'm doing, you can help support the show with the links below. As of today, 250 Steam keys for my upcoming game Chess Mess are now available for patrons at the $4 tier or higher. So if you want to check out my game and be part of the beta, you can go over there and become a $4 patron or higher, and you can get a Steam key and test the game, and let me know what you think of it. Well, I think that's going to do it for now. Thank you so much for watching. Make sure you like that smash button, and I'll see you guys in the next one.